Welcome. Thank you all so much for tuning in. We're so pleased you've joined us for the Southeast Ocean and Coastal Acidification Network State of the Science webinar series. The title of today's presentation is Vulnerability and Adaptation of U.S. Shell Fisheries to Ocean Acidification. This series is hosted by SOCAN, or the Southeast Ocean and Coastal Acidification Network, and is really intended to lay a foundation for the state of ocean acidification science in the Southeast region. It is our hope that these webinars will help create a dialogue among scientists to identify what is known, what isn't, and what research in other regions of the U.S. can be applied to better understand ocean acidification and its impacts in the Southeast U.S. With awareness of and access to the research and its applications, webinar participants will be able to collaborate to better understand and adapt to ocean acidification moving forward. I'm Jen Bennett-Mintz, Education and Outreach Coordinator for NOAA's Ocean Acidification Program, and I'll be moderating today's session on behalf of the SOCAN Steering Committee. During the presentation, all participants will be in listen-only mode, but you are welcome to type questions related to technical issues or questions for our presenter into the questions box in the bottom of the control panel on the right-hand side of your screen. We'll be monitoring incoming questions and respond to them or pose them to our speaker. We are also recording this session, and the recording and PDF of the presentation will be available on the SOCAN website. We are very excited to welcome our speaker, Dr. Lisa Suatoni, to the series today. Lisa is a senior scientist in the Oceans Program at the Natural Resources Defense Council, where she specializes at the intersection of science and policy as it applies to ocean conservation. Lisa focuses on a variety of topics, including ocean acidification, sustainable fisheries management, and operationalizing marine ecosystem-based management. Lisa has a PhD in ecology and evolutionary biology from Yale University and a master's degree in environmental policy from the Yale School of Forestry and Environmental Studies. She is also the Timothy B. Atkinson Environmental Lecturer in Law at Yale Law School, where she co-directs the Yale Environmental Protection Clinic. So with that, I will go ahead and, without further ado, hand it over to Lisa so we can hear about vulnerability and adaptation of U.S. shell fisheries. So Lisa.
Hi, Jen.
Hi there. Should be coming your way.
I don't see the, there we go. Thank you. Hi, everyone. Thank you, Jen, for inviting us to present the findings of this study. Today, I'm going to be discussing the first nationwide vulnerability assessment for ocean acidification. And because you guys are SOCAN, I'll focus on findings related to the Southeast and the Gulf of Mexico. This was a collaborative project funded by NSF Socio-Environmental Synthesis Center, and the group was led by Dr. Julie Ekstrom, who was with NRDC, but now is with the Davis Policy Institute of Energy and the Environment, and she's their Climate Adaptation Program Director. Unfortunately, Julie couldn't be here today to do this presentation, so I'll be doing it, and another co-author, Sarah Cooley, is on the line, as Jen mentioned. As you can see, this is a really interdisciplinary group. We had geochemists, biologists, economists, social scientists, and policy experts. And we came together on numerous occasions to do this national vulnerability assessment for the United States on shelled mollusks, but we also did a global vulnerability assessments focusing on a different taxon, focusing on the ecosystem services for corals. This first study, the national vulnerability assessment, was published in February in Nature Climate Change. So I'd like to begin by sharing some of the motivation for the study. In the summer of 2007, something was killing Sue Cudd's baby oysters. All of a sudden that summer, she and her husband and hatchery workers noticed that within a couple of days of life, their seed, their baby oysters would stop feeding, stop swimming, and die. And they were suffering losses of up to 80% that summer. So they were in a total state of crisis. Luckily, through partnerships and really meticulous research with scientists in the area, they figured out that ocean acidification was to blame. That waters that were particularly low in pH and carbonate saturation state were upwelling onto the continental shelf there, coming into their hatchery and killing the oysters within the first few days of life in a very vulnerable stage of life. Luckily, through state and federal investments in research and monitoring, the Whiskey Creek Shellfish Hatchery and others adapted their operations to this low carbonate water. They were able to save their business, and they're now currently thriving. But the experience sent a shockwave through the U.S. shellfish industry. And a lot of people started asking the question, who is next? Who is most vulnerable or at most risk in the United States to ocean acidification? And that's what really motivated this study. We wanted to ask 3 questions. Where should we be focusing our attention in extremely limited resources? Because as you all know, there's a great OA program that the federal government developed, but it has very limited resources. So if they were going to take all factors into consideration, the oceanography, the biology, and the potential human impacts, where would they focus their attention? Second question was, what can communities do to minimize harm? And we felt the vulnerability framework was a good way to examine risk and look at numerous and potentially creative ways to reduce that risk. And lastly, are we conducting the necessary research to prepare communities that are at risk? What are our research priorities through this lens? So our vulnerability assessment, like many vulnerability assessments, focused on 3 components. The hazard, in this case it's ocean acidification, economic dependence of a vulnerable resource, and the capacity of a social group to adapt and cope with the loss of that vulnerable resource. Now, this vulnerability assessment, I want to emphasize, was done entirely on shelled mollusks. And we did that because the research suggests that shelled mollusks are potentially the most vulnerable taxon. And we wanted to try to minimize our assumptions that we were making in terms of the biology. In this study, we're assuming that all shelled mollusks are equally vulnerable, which we know not to be the case. But we don't have enough research on economically valuable shelled mollusks to really parse that aspect of vulnerability out yet. But because this is through the lens of shelled mollusks, clearly it's just a first step to examining vulnerability in the U.S. There are other taxa, particularly in the southeast region, like coral, that are known to be vulnerable and would change this vulnerability profile if we folded them in. And that's certainly something that should occur as we have developed a better understanding of the biology of vulnerability. So in the first component, the hazard of ocean acidification, we wanted to look at not only the influence of rising atmospheric CO2 concentrations on the waters, the ocean waters around the U.S., but on local factors that might enhance or exacerbate that vulnerability. So we looked at 3 things. We looked at the strength of upwelling currents, nitrogen-induced algae blooms or eutrophication, and lastly, river water chemistry. The water chemistry, the carbonate saturation state of rivers flowing into the coastal zone and the volume of water that's flowing into the coastal zone. The second component was economic dependence or sensitivity. I use those words interchangeably throughout this talk. And we created an index of economic dependence from 3 factors: the value of the catch, in this case shelled mollusks, an estimate for the number of jobs, which we used the number of commercial licenses as a proxy, and the percent of total fisheries revenues in a region that was attributed to shelled mollusks. And lastly, we looked at adaptive capacity. And this is the ability of a social group, again, to cope or adapt to changes. We had 3 large measures for adaptive capacity in this study. And we really tried to focus this component on ocean acidification in particular when we could. So one component was alternative jobs. And we used 2 indicators for alternative jobs, or the ability to switch jobs. And one was the diversity of shellfish industries in a region. So how many different species are being harvested, and what percentage do they contribute to the total economic value of harvest? And in addition to that, we used a more generic measure, which was employment diversity for an area. Secondly, we looked at scientific capacity. Because the Pacific Northwest story had such a large, is really a successful adaptation story, at least as of yet, and science played such a large role in that story. We looked at 2 measures of scientific capacity, the Sea Grant budget and the number of marine labs in the region. And lastly, we looked at a measure of political support, and in this case, state preparedness. And we looked to see if a state had taken any action on ocean acidification. And we ranked that, and that was legislative action, and have they allocated money to research and monitoring or adaptation, etc. And we also looked to see whether a state had a climate adaptation plan as a gross measure of potential political support for doing something about ocean acidification. Now, before I go through the results, I'd like to mention an aspect of the study that may be a little confusing, and that is the geographic unit of analysis in this study. We set out to do this analysis on a really fine-scale geographic level, and we wanted to do it on the level of a county. But because of confidentiality rules associated with fisheries data, we were not able to do the economic dependence on the level of a county. We would have to bundle counties together until we surpassed the rule of 3. There had to be larger than 3 fishermen fishing the shelled mollusks, or 3 dealers in an area. So you're going to see the geographic unit of economic dependence vary depending on the region and how this rule of 3 played out. Okay, so this is what our data look like in terms of the 3 components. We had the spatial analysis of these 3 different indicators for hazard, economic dependence, and adaptive capacity. And vulnerability in our model is defined as economic dependence and adaptive capacity combined. So I'm going to walk you through the data step by step. First, we're going to look at the hazard, the influence of rising atmospheric CO2. And this is a global model projections of how ocean water chemistry is going to change in the future. And what we're looking at is the date at which these waters are believed to be problematic for shelled mollusks in the United States. And you can see the darker red is area at higher risk, because that's when shelled mollusks in these regions are going to probably encounter problematic water for them. And you can see clearly the large geographic signal that the northern areas are going to face problematic water sooner. This is not surprising, and the result of cold water being able to hold more atmospheric CO2. So the CO2 is pouring into those areas, and you can see Alaska, the Pacific Northwest, and down East Maine are areas that are going to be facing problems now or in the near future. And the area of SOCAN, the area you're interested in, so far from these global models has projections after 2099. That is not to say that these areas are not vulnerable to ocean acidification. It's just saying that the CO2 signal is going to be seen first in the northern areas. Now, these global models don't do a good job of predicting the date at which carbonate saturation will actually become problematic for bivalves in the coastal zone. And because of that, that's why we added on all these local factors that can actually accelerate this timeline. And so I'm going to focus on the East Coast and the Gulf of Mexico. And here we plotted these 3 local risk factors. The first one you're going to see is the rivers with a very high volume of water that are low in carbonate saturation state. In addition to that, we plotted the eutrophic estuaries. And this eutrophic estuaries is from a data set that NOAA has. We also plotted upwelling currents, but there is no strong upwelling on the East Coast in the Gulf of Mexico, so you don't see that local factor in this picture. And then lastly, we did a spatial analysis of the social factors. In this case, I'm showing you economic dependence. And here, dark purple is high economic dependence, and it ranges to the light blue, which is lower economic dependence. And you can see that there are areas all along the East Coast and the Gulf of Mexico that are highly economically dependent on shelled mollusk harvest. And in particular in the SOCAN region, you'll see the Carolinas showing up and the panhandle of Florida, in addition to some areas of Louisiana. Now, if we wanted to fold in adaptive capacity to this social measure, you will see a different profile. You see here I have the data set for economic sensitivity and social vulnerability. Recall that social vulnerability is a combination of economic sensitivity and adaptive capacity. And you can see that there aren't enormous differences between these 2 measures of vulnerability. In the SOCAN region, what we see is a slight shift. In the Carolinas, we see, and the Panhandle, a decrease from economic sensitivity to social vulnerability, and that's because there is some high adaptive capacity in these regions. You see that opposite shift actually with some of the parishes in Louisiana, where they're less economically sensitive, but they're more socially vulnerable. So these are the major findings of our study with regard to the East Coast and Gulf of Mexico, but I wanted to walk through some of these underlying data layers with you and show you some visuals that I think could be important to taking this study and utilizing it to the benefit of really closely examining vulnerability in your region. When we set out to do this federal study, we knew that we couldn't do it on the level of spatial resolution that would probably be most beneficial from a regional perspective, but we wanted to get a broad overview of the country as a whole. What needs to happen now is every state or each region should conduct subsequent vulnerability assessments similar to this to get a more refined understanding of where they're most likely at risk and how they might be able to adapt and cope and prepare for any changes that are coming. So here's a website that we produced with the underlying data for the study, and I have the URL up in the title. And I'm just going to show you some of these data that underline the vulnerability assessment. This one is rivers, and we have the rivers color-coded such that red is higher risk, and this is from the perspective of the volume of water that's input into the coastal zone and the chemistry of that water. And then there's kind of low vulnerability is in green. And you can see there are geographic patterns here in this region. Here is the eutrophic estuary layer, where we got the data from NOAA, and not all of the estuaries along the coast are scored. This is a very important data set that should be given some attention and resources for continual updating. But you can see that the East Coast and the Carolinas and Virginia have some consistently eutrophic estuaries. That really can be problematic for shelled mollusks. The research that's coming out on nitrogen pollution and the effect of eutrophication on carbonate saturation state is stunning. And for example, Chris Gogler has some interesting work in Long Island Sound showing that the bottom waters of Long Island Sound are some of the most acidic or the lowest in carbonate saturation that have been measured in the United States. They're quite close to becoming acidic. And so this local effect can be quite profound in an area. Here is the economic sensitivity score close up for your region. And I would like to show you the three components that made up this index here. As I mentioned before, their landed value, number of commercial licenses, and the percent of revenues from shelled mollusks out of total fisheries. And you can see how the different geographic units, what we call our county groups, change and shift a little bit from one measure to another. And it's this kind of underlying data that I think the states or the regions might want to dig through and get a better handle on what is causing their vulnerability and what matters most to them. And here is the adaptive capacity score for your region in the various counties. So what we learned, what we took home from this study is that the vulnerability framework that we use can be quite useful in understanding where attention should be directed and what type of research is needed. The vulnerability in the mosaic of vulnerability we see in the United States is quite nuanced, that some regions have very different challenges and assets that they can that they need to address. In the case of the Pacific Northwest, for example, their cause of vulnerability is that they're in a northern area with very cold water. They have a local factor of upwelling, and they have significant river input of low carbonate rivers, and they have eutrophication in certain regions like Puget Sound. So where they have really important, valuable shell fisheries, they've got all four challenges in operation. But they also have some assets that they can work with to hone and try to adapt. And some of those assets are the fact that a lot of this industry is aquaculture. And so they're protecting the very delicate juvenile life history phase in a controlled environment. They also have numerous species that they're harvesting, and they have a very active state government that's not only passed legislation but has allocated money to adaptation and to mitigation. And they, and they have very active local partnerships with scientists. The vulnerability profile of a place like Virginia is quite different. Its challenges are in terms of the river water input and the very strong cultural eutrophication that they're facing. They also have low commercial shellfish diversity for the most part, and they may want to invest in shellfish diversification of their shellfish portfolios. There is little action from the states in many of these cases, and so right now they're not getting a lot of support on a state or local level. However, they have some assets that they could utilize should you all want to reduce your risk, and one is the warmer water, and another is local pollution. Your largest risk factor is in the form of eutrophication in many cases, and there's a lot that can be done to reduce nutrient pollution in the coastal zone. And there is a lot of law and regulations on the books that could be brought to bear on that. So that is the presentation. I'd welcome any questions to take a deeper dive into elements of this study.
Great. Thank you so much, Lisa. That was a really fantastic and informative, and thank you so much for really sort of pulling things apart and honing in on the Southeast. So We will open the floor for questions at this point. If you could please type those into the comment or the questions box in the control panel, that would be great. And as Lisa mentioned, Sarah Cooley, a collaborator and co-author on this work, is also on the line to answer questions as well. So we have two really great resources to answer any questions coming in. So please go ahead and type those in for us. And I do have and Lisa, I don't know, you know, I saw, you know, you mentioned sort of the difference in adaptive capacity between Florida and Louisiana. And I was wondering if by chance you recall or have an idea of what those differences were in those states, or have a sense of that.
And that's a great question. So I'd like to go back to that slide. So one thing that stood out in terms of these high social vulnerability scores, is that a lot of these areas have low capacity because they're harvesting a monoculture. They're harvesting only one species of mollusk. In addition to that, they have low government support. And you can see that Florida has much more higher capacity than much of the Gulf of Mexico, right? And that's largely because of, you know, they have a larger sea grant budget, and they have ability to switch jobs easier and things like that.
Great.
You can go on the website that the URL is showing and really home in on that and look at the different capacity measures, because there are a number of them.
Great, Lisa. Yeah, and you all, there is the link in your questions box to that great resource, and it is a really amazing place to dive in on the NRDC website. So we do have a few more questions, Lisa. Zachary Johnson is wondering, what were the biggest holes in your data set, and of course, how do we fill them?
Oh, I'm so glad someone asked that, because one thing that I failed to mention, and that was ultimately when you do a vulnerability assessment, you want to roll up all three components into one vulnerability measure. And, you know, that's the ultimate goal, and we weren't able to do that in the end. We were able to combine economic dependence and adaptive capacity into a measure of vulnerability, but we wanted ultimately to factor in the hazard with social vulnerability to get a total vulnerability score, and we weren't able to do that because we weren't able to combine the different physical elements of the hazard. Because we really wanted to include local risk factors, we could not find a group of scientists who were willing at this point in time to come up with a method for merging all of these factors into a single hazard score. People didn't have a good enough understanding of how to weight eutrophication with river water input or upwelling, for example. And so this is one area that I would identify as a gap. And obviously, if we had a lot of monitoring and water chemistry measurements in the real near coastal zone, we wouldn't necessarily have to rely on this kind of spatial analysis of local risk factors. We'd have a much better understanding of what the water chemistry is as a result of all these local factors. So really one of the biggest factors or one of the biggest gaps is ocean chemistry. But I don't want to leave out that whenever you do a study like this, there's always the gap of social data. And we wanted to do this study really, again, on a small geographic scale, and it was difficult to get a lot of the social adaptive capacity data on the level of a county or the scale that ultimately we would want. You know, you really want to do this on the level of a community, and it's difficult to get some of the data on that scale. And I wouldn't identify the economic data, you know, this problem of confidentiality is a gap, but it was a challenge in the study, and it would be great to get permission to do this analysis with confidential data, and eventually if you create indices you can mask it, and our inquiries to get access to the confidential data were denied.
Well, that leaves us with with a couple different avenues to move forward with. So thank you for that, Lisa. And Zach, if you have any follow-up to that, just please go ahead and type it in. We have another question from Lee King. He's wondering if there was any studies on the effects of groundwater to the acidity or pH, carbonate chemistry of these regions that were taken into consideration.
I'm going to let Sarah Cooley answer that one.
Awesome. Sarah?
Hi, Lisa. How are you? We actually did not incorporate any studies of groundwater because we could not find a comprehensive set that brought everything together for the entire United States. And that was, it may exist, but we were just not aware of it. But even if we had been able to do that, we would have had to include it in the way that we did eutrophic estuaries or river water discharge. We would have had to include it as a fourth environmental factor that we didn't know how to mechanistically link with the other factors. And really that kind of goes back to what Lisa was saying, how we really identified that as a knowledge gap. In every coastal region, the relationship between oceanic water, river discharge, groundwater, and production in situ varies so substantially that we were really unable to come up with a way to roll up all of these things together without having detailed models that really provided insight into the hydrodynamics of the whole system. So I think incorporating groundwater would have been fascinating and very, very illuminating for certain areas, but we just couldn't do that in this study.
Thank you, Sarah. So we have another question from Mike Buckman. He's wondering about, he had heard that or understands that Taylor shellfish in Puget Sound eventually left the state and built a $3 million hatchery in Hawaii to settle spat and then transfer them back to Puget Sound just for grow out. How does a factor like this factor in to your economic assessment? Or did it at that point? I don't know if that had happened in your study at that point.
So Sarah, why don't you take that one too?
Sure. It's actually not true that Taylor has left. There is a hatchery that has been built in Hawaii, but it's sort of a backup. It's not a complete retreat from the area. I think that factors into the suite of, I don't know, second order capacity to adapt, and we didn't look at that kind of thing in this study exactly. In areas where there was heavier dependence on the shellfish resource, plus I guess I would say a bigger business around it in places like the Pacific Northwest, there's a real potential for those sorts of I don't know what you want to call them, completely out of the box adaptations that can be applied. We did not look at those in our capacity measure, but in subsequent studies, my colleagues and I are looking at what factors will lead to those kinds of actions and how universal those actions could be for other areas. So that's why I say no, we haven't really incorporated that kind of thing in this study because it kind of fell outside the set of specific measures we wanted to use for adaptation, and it's kind of like a second order one anyhow. So, but in the future, we could include it. Next time we start this study all over again, right, Lisa?
Yeah, no, and mobility is a great measure of adaptive capacity, and so, Julie Ekstrom is not here today, but her specialty is in adaptation, and that component is really rich it's a rich component with lots of facets, and we didn't capture all of them. And it does seem to be, again, one of the more challenging factors to get data on.
Mm-hmm. And plus, your statistical power is going to be pretty low because there are only going to be a few companies that have enough economic oomph to be able to take such steps. For the most part, the growers and shellfish industry folks who are involved are pretty small scale. The hatcheries in the Pacific Northwest are really exceptional in terms of how large they are and how much of the industry in that area they actually represent, because of being this sort of almost a bottleneck point. Everyone gets their seed from these hatcheries, whereas in different areas where you have different wild populations that are being harvested, or you have smaller scale hatcheries, the business dynamic is a little bit different.
Great. Thank you, Sarah and Lisa. So sort of along those lines, and I know you mentioned that Julia isn't here today, there is a question from Amber Himes-Cornell. She was wondering if you could explain a bit about the method that you used to create the social vulnerability index.
Lisa, do you want to take that one? Because you and Julie worked closely together on that piece of it as it evolved.
So you're asking specifically for vulnerability?
The social vulnerability, yep.
The social vulnerability. Okay, so we created these fairly simple indices with the components. I'm going to scooch back to, oh, I don't have a slide with them all listed, but we created a simple index with the components, and I'm trying to look at my math. I think I might have to refer you to the paper, Amber, because I don't want to get the mathematical equation wrong, but I can follow up with you.
Yeah, and Amber actually wants to let you know she's with the National Marine Fisheries Service, and they've created some similar indices, and she actually has expressed interest in linking up with you to compare methodologies and lessons learned as they move forward with improving their indices, and you both move forward. So I let her know your email will be available, and I'm sure she'll be following up with you. So yeah, we've had some great questions thus far. And Amber is looking forward to seeing the paper. She'll dive in. If there are any other questions, go ahead and please type them into the questions box. And yeah, let's see if any others are coming in. Awesome. And just out of curiosity, and I don't know, again, if this is on the top of your head or not, Lisa or Sarah, but can you just give us a sense of what some of those bivalve mollusks fisheries were that you saw throughout the Southeast and the Gulf, the dominant players there?
Yeah. So in the Gulf of Mexico, it's single species. It's just oyster. And except for in Florida, where we had, oysters and clams, and we had largely, again, it's mainly oysters and clams in the Southeast.
Huh.
And this is one reason why the Southeast is a little bit, has, issues with adaptive capacity because of the low shellfish diversity compared to other parts of the country. I think, Delaware had the highest diversity index of any of the states. But, the Pacific Northwest and the Northeast has a lot of species they're fishing. So hard clams and oysters are mainly the name of the game in the Southeast.
That's right, and as I understand it, there are some wild species that are kind of collected on a recreational basis, but because they didn't show up in the industrial side, we couldn't use them, and so the diversity scores wound up being extremely low in that part of the country.
Ah, okay, great, thank you. So we have a few more great questions coming in. Let's see, we have a question from Wiley Evans. He says, you mentioned the importance of doing similar analyses at the state level to resolve finer scale detail. Would there be any benefit to scaling up to the continental level? Many industries, specifically shellfish, aquaculture, crosses borders, so that perhaps a larger scale analysis that includes data from Canada and Mexico may have some value. Any sense of comparable data sets in these countries?
So I think the value of what scale to do the analysis on has a lot to do with what your goals are. And in this case, we were very interested in generating advice for the national program, the national OA program, and how they allocate their funds and whether or not they're conducting research that will really reduce risk for humans. And so I think you would have to have potentially a political reason to scale up to the level of a continent. These vulnerability assessments are deployed as a way, in part, to inform not only research but political decisions. And it's not entirely clear to me why the scale of North America would be useful. There probably are good reasons, but I can't think of them off the top of my head right now.
One thing to add to that, Lisa, is when you're looking at even nation scale data and you're trying to do vulnerability indicators or adaptive indicators for the nation scale, a lot of times you will lose a great deal because the most appropriate, or I guess most typically used social science data indicators for things like vulnerability or adaptive capacity are things that are sort of macro scale variables. They'll look at, GDP per capita for the whole country, which includes a huge amount of non-coastal industries and natural resource use. So that's one of the scaling issues that we typically run into when we're going in the reverse, when we're looking at a nation, trying to consider how one would apply a national scale analysis type of thing to a local area. You can't use U.S. GDP in our particular study because we would just get no distinction between any of our areas, and so there's kind of some discussion about what the best social science indicators are to use to indicate vulnerability and sensitivity. And I think trying to figure out exactly how to apply something this nuanced at, regarding the industry, that is, kind of with all that industry detail collected in it, might be hard to find when you're looking at the national scale as well. Not every country collects the same data, and if they do, it's not necessarily aggregated in the same way. It might be all commercial fisheries instead of the taxon that you're interested in, shellfish. So I think it could be quite challenging if you did zoom out just in terms of a data intercomparability question between nations.
That's a great point, Sarah. Thanks. So Deborah Hernandez is wondering, based on your work, where do you think the highest priorities are for work in the Southeast? And if you can, what is the nature of the work that should occur?
I think we can both take a stab at this, but I would say that one of the highest priorities is in the Southeast is really getting monitoring data in some of the coastal waters, and I think it's justified to do that in regions that have thriving businesses right now. So in the Carolinas, in the Panhandle of Florida, and try to pick a couple of pilot studies where you try to integrate the information about river water input and eutrophication, nitrogen pollution, and their interaction potentially with the biology of the mollusks that are being harvested there. Mm-hmm. So And then I have to say this, because our study was only on shelled mollusks, and we can't leave out all, coral reefs, that some attention, and I know attention's already being given to monitoring in the Keys, but some attention to some of these factors, better understanding these dynamics in relation to a coral, an important coral for tourism or reef fisheries.
Mm-hmm.
Great.
And I think, speaking from the social science side, I think one of the most useful steps forward would be to have conversations with resource managers and planners in the areas that we identified as having higher economic dependence or higher social vulnerability, and kind of having a dialogue about, well, what do you see as the most pressing issues facing this industry? Is this something that is even on your radar screen? If it's not, why not? Are there ways that we can strengthen your community against a whole suite of things by improving, I don't know, well, any one of these variables that seems to be low in your area? That was kind of the perspective that we took in the Alaska study that Julie and several colleagues and I were involved in that preceded this one. The results really showed that social and economic vulnerability varied greatly between boroughs and census areas in Alaska, and it was for a whole different host of reasons. And in many cases, it had nothing to do with the commercial fishing industries. And it's reasonable to think, if you have a conversation with the community, well, how can we future-proof you against all sorts of change by improving, I don't know, perhaps education, or perhaps food access, or something like that? Are those things that we can do to strengthen your community and then get an extra win against ocean acidification and global change? So I think a conversation on the social science side would be really useful to have in these areas as well, to kind of help scope out what gaps other groups feel need to be filled, and see if there's synergies between those issues and ocean acidification.
Thank you, Sarah. We do have, I think, one last question, unless others come in. Beth Turner is wondering if you have done any tracking to see what the impact of this assessment has been, and if certain states have taken it up or others didn't. If you know sort of any of the follow-up that came after this publication was released.
Well, we got a lot of good press coverage across the country on this study, which I was a little surprised about. We've had about 700 media hits in the week the study was released. Mm-hmm. And there definitely has been some follow-up in areas that hadn't previously been that interested, for example, in Connecticut and Long Island Sound. I would say this study seems to have played a role in getting the interest of people in Long Island Sound and Connecticut and New York, in trying to contemplate whether or not, for example, the Long Island Sound study should incorporate ocean acidification into their monitoring or research. And it's gotten the attention of some decision makers from that state.
Mm-hmm. In addition, Lisa, there's the Coastal Communities Vulnerability Act, which is, I believe, in committee right now at the federal level, which would amend 4AM so that the sort of primary federal legislation concerning ocean acidification research and monitoring that was passed in 2009, and this bill would actually amend that to request that NOAA do these sorts of vulnerability analyses for coastal communities in relation to their exposure to ocean acidification. So, I think that this approach has captured a lot of people's imaginations in terms of what can we do to be more strategic with our research and how we apply it to decision making. So I think that's been a really, really positive and kind of surprising to me too outcome, because this study was very packed. It was very, very dense with details and how we combine things, and all of these sort of nuanced outcomes, and I think for the most part people have been really hungry for that kind of nuance, whereas we kind of said, this could just blow people away because we're trying to jam a ton into one study. So I think that's been really gratifying and pretty interesting to see how it's shaped the conversation since.
Great. Yeah, I know being in the OA community, it's yeah, definitely been referred to, and many people are inspired by the work and refer to it as well, and it serves as a baseline for many studies going forward. We do have a few more questions. So Abel is wondering how the social vulnerability index can be used at the state or local government level. For example, what does it mean for a county to have a high social vulnerability index? Could the county have access to the data of the main factors that contribute to high social vulnerability to address the most important issues at the local level?
Lisa, is that information on your website? Can you drill down that far in the website?
Yes, you can.
Okay. It's also available in the supplementary information in our paper.
Great.
I don't know if it's at the county level, but certainly we could always have that conversation with an interested group and dig out, all of our yucky looking Excel files and things.
All right. Well, and on that note, we do have the link to both the NRDC resource, that map you can dig down to the various layers in the questions box, along with a link to the publication. I know some folks were curious about that. We will also go ahead and share Lisa and Sarah's contact info in the questions box in just a minute or so. And yeah, I just want to, I think we're going to wrap up here, and want to really thank both Lisa and Sarah, and I know the team, your co-authors, for first of all doing and sharing this really important work. And I really appreciate the participants' great, thoughtful questions as well, and for everyone for taking the time to join us. I do just want to let everybody know on the line that we do have an upcoming SOCAN webinar. It will be 3 weeks from today, and that is going to be on November 10th, if I can show you guys this in just a moment. So yeah, we will, let's see, hopefully it's working. There we go. Great. So we do have an upcoming presentation in the webinar, and I know many folks were curious about where the PDF of the presentation, or will there be a recording available. This presentation was recorded and will be available on the SOCAN website, which you can see the URL here, the website information there. If you do have any questions about the Southeast Ocean and Coastal Acidification Network or the webinar series, please, you can contact SOCAN at socorro.org. And if you are interested in learning more about ocean acidification and coastal acidification in the Southeast, please to go ahead and contact that email as well. There's a listserv for this network. And with that, we'll just let you all know that next webinar will be about 3 weeks from today, and information again on that presentation and the info to register will be available on that site. And thanks again to Lisa, to Sarah, to all of you for taking the time to make this a great webinar and discussion.
Thank you, Jen.
Thank you.
Jen.
Bye-bye.
Bye-bye.
Bye.